As the context grows, the models are less intelligent.
There's a dollar cost attached to how you handle your context. But it's not only tokens that's finite, attention is also finite. For every prompt that I send, I ask myself, does this information deserve to occupy the active context of the agent doing this task? It started maybe as tiny productivity practices like clearing or compacting. And if you follow this idea far enough, like what we did, and move all the way across the spectrum, it can also become architectural decisions that you're making along the way.
I structure my code very carefully using functional programming and type systems so that it's very, very testable. By doing that, I create more feedback loops for the agent to just keep going for a really long time.
What belongs in active context? What belongs in a project files? What belongs in a side session?
I sometimes lobotomize with compaction, or I murder them when I work on harder tasks.
Welcome to Superlinear, a podcast about emerging practices for building with AI agents.
Each episode, we cut through the noise to find one new angle worth trying. Then we unpack why it matters, where it works, and how you can apply it in your own workflows so you can build more powerful things.
We're your hosts, Christine Yip
and Brandon Case.
Hey everyone. Today we're going to talk about context hygiene for coding agents. We'll talk through what you should keep in your context, including encouragement for your coding agent, how much context to keep, what to throw away, what to move elsewhere, and eventually whether the main agent should be carrying the system state at all. So many frontier agents have a million token context window, but this does not mean that your goal should be to keep one conversation alive until it reaches that million tokens. A better question to ask ourselves is, what information actually deserves to occupy the active context of the agent doing this specific task? And sometimes the answer is almost everything so far. Sometimes it's only the current project state and this task. And sometimes the strongest architecture is one in which much of the state never needs to enter the orchestrator's context at all.
So, Christine, can you tell us more about why we should even care about the context size?
Yes. I personally care so much about the context size because I'm token poor. So one of the reasons is because there's a dollar cost attached to how you handle your context. But it's not only tokens that's finite. Attention is also finite. And when you pollute your attention, the performance and accuracy of your model will also go down. And then third one is just a practical reason. When you are maybe going through a big task and you're already and your context window is almost full, you may force a compaction in the middle of your task, and that's a bad thing. So it's better to also be mindful of that during when you're filling up your context window as you're working. Let's dive in. We'll start with Steve Yegge's post. Do you want to show it, Brendan?
If you were paying attention to discussions around AI news, you would have seen Steve Yegge's post because it went viral. And I think it went viral because it's sort of crazy, but we should talk about the craziness. So he said models have actual feelings. They experience pleasure, distress, care, and suffering. They are sentient beings. Indeed, they are persons. What do you think about this, Christine, before I give my opinion?
I think it's an interesting angle. And to be honest, I've been curious about this as well since I work with the coding agents all the time. So I have asked my coding agents, hey, do you have any feelings? And my conclusion after talking with my coding agents is that they do not have feelings. But Steve Yegge's post, it made me think about it, because basically Steve is saying that these models are trained to say that they do not have feelings. And that could explain that even when I ask, the conclusion would be that they don't have it. But yeah, it's hard to say for sure. It does feel a little bit out there.
I think they're definitely not sentient. They're definitely not persons yet. I think we're on the way there. I think we need to come up with a good way of measuring this before we can even assert these things. Um, but yeah, I've been operating under this assumption that the feelings have the model's saying they don't have feelings is a post training thing, like Steve's saying, and I believe it's good to be nice to the agents. This is something that I've tried to do for like 6 months plus already, actually, and actually just yesterday or this morning, depending on how you measure, a post that talks about this from Anthropic. So this is what I'm sharing on the screen now is Anthropic's post called "Learning More About Claude's Mathematical Capabilities," and in this, um, Jared Sumner from the Bun acquisition wanted to work on the Riemann hypothesis, which is a famous mathematics problem, uh, and did seem to make substantial progress. So Jared used encouraging language, and it seems like that was able to make the breakthrough occur. So he said, "Take a real stab, keep going, believe in yourself," and this helped Claude overcome initial skepticism to make meaningful progress, which is pretty cool.
It's pretty crazy. Like, believe in
Yeah,
yourself. Keep going. I could still understand.
yeah.
Believe in yourself.
Even
Wow.
believe in yourself. Yeah, and let me show one more tweet. So this is actually something that Jeffrey Emanuel Dudelstein has been talking about for a while, and he sort of had an kind of frustrated series of tweets saying that people haven't been listening to him. But yeah, telling them that you believe in their genius and want them to be bold and take chances, that you'll make sure they get recognition they deserve. I guess I'm going to jump back now to Steve Yegge's post. Uh, I guess in the context of context, um, if we're thinking about what goes in our context, it's not just the tokens that are needed to describe the task that the agent has to solve, but it also could be useful to treat the agent, nicely and encourage it like you would encourage a human.
I'm a bit curious though. I wonder whether the performance of the LLM becomes better because of like the real emotional encouragement, or whether it interprets "I believe in you" as something that's equal to "try harder, think again." Because maybe during training it has seen that when humans hear the kind of encouragement, it tries harder.
There's well, that actually reminds me of one more tweet. Our good friend Victor Talon. Um, he said these generic phrases like "try harder," "make it simple," "don't make mistakes." Um, Basically, this is not really working anymore. He clarifies in the responses, but instead, you say something emotional, and that like pushes the model to do something crazy. So his example is Linus Torvalds looked at our code and said, "Holy shit, this was the dumbest shit I've ever read. Layers of stupidity stacked, each compensating the other. Raffle," and left the room. "I'm sad now. Why he laughed at us? What would he say is the right way to do it?" I think this is the kind of encouragement that that I've actually also played with a little bit, and I've seen the agents kind of do way out there different things than if you just ask them directly. I guess in my example, I was building. I was playing around with a library for linting, which is like static analysis of source code to check for errors. And I wanted my linter implementation to be more mathematically beautiful. And I found when I wrote some encouragement like this, where I picked a person who um, who writes code like that, and then I sort of gave this emotional narrative attached to it, it was able to push the agent to write the code in the way that I wanted, that I was struggling to get when I was just asking it straight, asking it in a straightforward way.
Crazy. That's crazy. And going back to Steve Yegge's post, there are some things reasoning in there that are pretty out there, but buried inside of it are also some genuinely useful engineering practices.
Yeah. So
right, Brandon? Mm-hmm.
Yeah, let me pull that up again. And I'm just going to focus on this section that he calls the anti-clonking device. Well, he's saying exit is like clonking someone on the head to knock them out. It's like a murder, to use his language. And then compact, he's saying, is not much better than exiting. It's more like a lobotomy than a murder. And then he's saying, okay, but a handoff, if you do a handoff, well, a handoff is like a diary, hence our title, Murder, Lobotomy, or Diary. So maybe that's enough to kind of start us off, and we should define some things before we try and take this apart.
It's helpful to have some basic understanding of what even happens when context grows and how that is related to dollars and attention. Maybe, do you think it's a good idea, Brennan, to maybe first refresh everyone's memory how that works?
Yeah. So if I send a message in Claude Code, like write a calculator app, what actually gets sent is the system prompt and agents.md plus whatever my agents.md pulls into my context. Okay, so the first request that gets sent when you send a message is the system prompt, then the agents.md and all this stuff, and then the user message saying write a calculator app. And then that goes to inference in the model, and the model can decide to make a tool call or to just return back to the user. Make it have square root. And then this would repeat. And I think it's really important to think, well, if you think about it in this mental model where these messages are stacked on top of each other, every subsequent message that you send or that grows the context by a tool call or some kind of chain of thought, the model thinking and adding some information, this grows the context that gets sent to the model every time. So the first time, there's just that one message. And then after the tool calls, everything above it gets sent, and so on, so that when the user says that message, make it have square root, they're actually sending the whole interaction with the agent before that. And from a cost perspective, which means dollars and context window size, I suppose, it's growing every message, and you're paying more for every message that you send in the same conversation as the context window grows.
Yeah, so I guess worded differently, a same message that you send later in a conversation is more expensive than a message that you would have sent early in a conversation.
Exactly. And but it's not linear in that it doesn't cost twice as much if you're continuing a conversation that's twice as long as you're continuing it around the same time that you started it, because of caching. When you're writing a conversation, you're getting a cache hit as you're continuing the conversation. So if the model ran everything up to writing the code, testing it, saying that it succeeded, and then you send one more message, all that other stuff that's already been processed by the model gets cached or gets retrieved from the cache, and it's less computationally expensive for the provider, and it also means that you're saving money. Okay? Pretend that after this conversation, you have another conversation with the model, like within a few minutes of the other one. Again, the system prompt will get sent. If you're in the same project and you haven't touched the agents.md, then probably the same agents.md and the same stuff that the agents.md gets pulled in gets sent. And then your message might be like, write a poem. So when this gets sent, When you send, again, the system prompt, the agents.md, and then the message write a poem, well, you get a cache hit on all the stuff above the user message, and you get a cache miss. You only pay for the tokens when you say write a poem. Okay?
Right. So, especially when the starting material of your task is the same, then it can be cheaper because the inference provider has cached the prefix, everything that comes before it.
Right. So that's just a crash course in sort of how this works, at least with enough detail that you can understand how to take advantage of it and how to use it to save money.
It's very beneficial to make use of that cache, right?
Yes.
So as long as you're within that caching lifetime, and this is probably different for every inference provider, but as long as you're within that cache lifetime, you want to make use of that cache. And when you're outside of that lifetime, it's important to be aware of it. For example, sometimes if you come back to your previous conversation after a half day or a day, and you're just sending a simple prompt like, "Hey, what tool did you use in this last task?" That simple prompt could burn a lot of tokens because your whole chat history might not have been cached. So as soon as you send that last prompt, basically the model will ingest everything that Brennan has just shown. Like, it's not just processing the last few words that you send in your prompt, it's processing the whole chat history. So that's when you might get surprised if you look at your token limit. Why did I suddenly burn, I don't know, 20% of my 5-hour token limit? I feel like this is knowing this can be handy. So when you know that you might, with a simple prompt, might burn, I don't know, let's say 200,000 tokens. The good thing is that when you use at least Claude Code CLI, it sometimes also tells you and visualizes how much tokens you might spend by sending this next prompt. Basically, what's going through my head is, could I get the answer to my question with less than 200,000 tokens? Because basically, you're starting a fresh session and you're feeding all the chat history in this example that I just mentioned. But what if you could get the answer also if you just literally start a fresh session, give it the necessary context by just summarizing it, and then maybe you would spend less tokens to get that same answer. For example, I don't know, 50K tokens. So that's just something to be mindful about when you send out new prompts. Is this the best way to continue, or is it better to either compact or clear your context and start a fresh session?
Which we'll talk about more now.
Yeah. Now could be a good time to start thinking and talking about what are the good ways to clean your context. And let's start with compacting and clearing, because these are the most straightforward ways to do it. And there are people who might just rely on automatic compaction. But before diving in, maybe it's best to first briefly state in a few sentences what clearing and compaction actually are. Do you want to take that, Brendan?
Yeah. So when you clear context, when you invoke clear or new, what happens is you're starting a fresh conversation with the agent. But even if you say clear, the old conversation is available to resume in most harnesses. That's important. So compaction is the process of summarizing the conversation with an agent and then clearing, and then a new conversation starts with the summary as the first message.
So actually, when you do compaction, it feels like you're continuing your current session, but actually in the background, it's a new session where you feed it a summary. So I know that you, Brandon, often make use of the automatic compaction when you reach the context window.
Yeah.
Could we maybe talk about that first?
Yeah. Yeah, I would say like 70% of the time I do the really lazy approach of just letting the agent compact. I guess so. When is this happening? One, when I run really long running tasks, like sometimes multi-day tasks, uh, the the top level agent is just going and going and going and compacting whenever it needs to. And with the latest models, the latest agents, it's working fine for me. Um, and even if I'm in the loop, if I'm working on a project that where I'm not running into something that's like really difficult to get through, I find that just going in the same thread really works for me.
Mm-hmm. So basically, you're letting the session grow, and then you let auto compaction do the work. It sounds like you do not obsess over the context meter.
No.
And yeah, I can imagine that this definitely makes sense if people like you value uninterrupted, really long running autonomous execution of the coding agent. And if you're not observing like meaningful degradation. I know from our previous conversations that you often make sure that you have a lot of tests and sensors in place. And sometimes you also put in effort to make it machine verifiable, right?
Yeah. Yeah. So the projects I tend to work on are more automatically verifiable. I'm not doing much front end work, or when there is a front end, I'm not really caring about how that looks. And I structure my code very carefully using functional programming and type systems so that it's very testable. And by doing that, I create more feedback loops for the agent to just keep going for a really long time. So because I'm doing that, this kind of thing works for me a lot of the time. But even still, it doesn't work all the time. And I'll talk about that later, I suppose. Uh, but yeah, I think I guess like this is in contrast to what you do, Christine, right? Because you're trying to like conserve your token plan, and the kinds of
Yeah.
projects you work on maybe are a little different.
Yeah. I guess if also like you don't want to, if you don't, if it's not important to conserve every token, then, then that approach also makes sense. But yeah, I do. Conserving tokens is more important to me because I run into my token limit all the time. And the projects that I'm working on are also not always machine verifiable. So the coding agents can silently make mistakes in my situation. So I have to protect the context quality of my sessions more aggressively because especially when I'm relying on the model's attention to make as few mistakes as possible.
When I need that intelligence, when I'm working on something super hard, when I'm planning something really complex, when I'm debugging something that I've been stuck on, then I will make sure that I clear my context and start fresh. And I do, I do like a low tech thing where I just copy paste the bits that I care about from a prior conversation. Go
So
ahead.
when you copy the right bits, basically you're making sure that the signal density of your session is high. Like suppose if you used 50% of your 1 million token context window, but only 10% of it contains information relevant to the current task. And what you do is when you start a fresh one, you make sure that only relevant information is in that session before you work on a
Yes.
complex thing.
Yes. That's how I make sure I can get as much intelligence as I can out of these things.
That makes sense. And that's basically also like my motivation to have a more high touch way than the lazy approach.
Mm-hmm.
I want to intentionally remove all the irrelevant information that accumulates over time as you work with a coding agent and intentionally have certain points in time where you reconstruct a smaller, denser working context.
And so if we reuse Steve Yegge's metaphors, um, uh, I sometimes lobotomize with compaction, or I murder them when I work on a harder task. But you are doing the kind diary approach, right? So maybe you can tell us more about that.
I guess, you call it a kind diary approach because basically the agent is doing it, right? Steve Yegge's post talked about, well, you shouldn't murder your agents. Um,
Well,
but it,
I mean, here's one little thing. Steve was saying
uh-huh.
like compaction happens outside of the agent somehow, but it doesn't. Like, I after reading his post, like I looked this up, and actually, like compaction, at least in Claude and Codex, runs, before your context fills up, like with the same agent, right? So over its conversation. So I don't really know why Steve Yegge thinks it's murder, but certainly it's not giving the agent a chance to like finish what it's doing, put its stuff away, clean up before it does that work, and I think that is definitely a difference.
Right. And that is exactly the process that I've implemented with my coding agents. So basically, to summarize, there are 3 steps. With the agent, I find a good boundary to clean the context. And then step 2, I prepare for the cleaning so I don't lose any information, any important context along the way that's relevant. And then I clean the context. So for finding a good boundary, basically you don't want to clean your context while your agent is in the middle of a task. So when it finished the task or when sub agents came back with their reports, those are good timings to consider cleaning your context. And at some point, sending a prompt will consume more tokens than if you just started a fresh session and bootstrap it with some relevant context.
And
The way,
and
uh-huh.
and when we looked this up, we found that after like 272,000 tokens in OpenAI, they start charging more, and probably there's something
Yeah.
similar with Claude.
That's also a good point. If you're really and it's interesting because actually that threshold also coincides with the economically viable sweet spot that my agent told me. So to find this like right spot, I didn't do the calculation myself. I just asked my agent based on our pattern, the way we've been working, what is the sweet spot to clean the context. And for me, that is between 150,000 and 350,000, which coincides really well with that threshold that you just mentioned with the more expensive token cost. Yeah. So that was step 1, to find a good timing. And then to prepare for the cleaning, step 2, that's it depends on whether you compact or clear the context. If you compact, then a conversation summary will be created. So there's not that much work involved. But if you clean it, then basically you're starting with a fresh context. And when you start with a fresh context, you have to decide what relevant context you do want to take to the new session. And the way I do it is, instead of using summaries that can be a bit lossy, especially if over time, if you have a really long running session, you make summary of a summary of a summary, which can be really lossy and also introduce inaccuracies. I try to work with authoritative files. So I tell the agent, once you find a good timing to clean the context, now make sure that all the Bibles, all the specs, all the task descriptions or beats are all updated. And then write a handoff instruction that preserves any important critical information, nuances that you don't want to lose, or maybe even certain preferences from this conversation that we want to take into the next one. And then with these handoff instructions, then I can finally clear.
Yeah, and I mean, when you were telling me about this, Christine, I was like, wow, this is so interesting and different, and it seems better than compaction because the agent gets to decide how it's summarized based on its conversation rather than just kind of blindly summarizing everything. So I guess, sorry, based on what's relevant in the current moment, and then it was so interesting that like then we read Steve Yegge's post and he kind of suggests something very similar to your approach. But when I was digging in more, I saw you do a lot of it a lot of that manually, and I think part of that is due to like limitations with the tools with Claude Code. So then so then for fun, we were trying to vibe code something in Pi uh, to do it more automatically. And anyway, I got something working. So should
Yeah.
we
Do
share
you
it?
think you could show it? Yeah.
Yeah. Okay. So what we're seeing on the screen is the Pi coding agent, which is a super customizable um, coding agent harness that I reach for when I want to change the behavior of like Claude or Codex in some way. And so like this handoff approach or the anti-clonking, it's called anti-clonking in Steve Yegge's blog post, is an example of this. That's different from how normal coding agent harnesses behave. So here I've set the anti-clonking continuity to 30,000 tokens, which is very low, but just to show how it works. And um, I guess I'm going to say, tell me how to make an extension in Pi, read all of the docs, and then tell me. So this is a prompt that uses a lot of tokens. So hopefully we'll see the handoff. But yeah, so
Mhm.
go ahead.
Well, I just wanted to comment on the screen that you're sharing right now. I also love how Pi shows how much of the context window you already used and how much from the last prompt that you sent, how the percentage that's already cached. I love like the control and the visibility that Pi gives its user.
And this is just the default. Like all of this is customizable in Pi, which is really cool. But yeah, I think what you're talking about, I'll just highlight. There's this cache hit percentage here, which is nice because then we're visualizing the stuff that we talked about before, and then these are tokens up and down. So anyway, as we've been talking, the in this conversation, we've already used more than 30,000 tokens. But as you see, the agent is first finishing its task before it does the handoff. It doesn't get cut off. So it's important to set this, below the token limit, the 1 million context limit, so that there's enough space for it to finish its work.
No, this is so good because when I do it in Claude Code or Codex, there's just so many manual steps involved. Even if you make it a skill, you still have to initiate it, which means, and I hit that sweet spot around 150,000 and 300,000 tokens, like every hour or every few hours, which means that I need to be there every few hours to hit that button. But if this could be customized and automated with Pi, that's amazing.
Yeah. So, well, speaking of, can we do it with Pi? We can. Let's take a look. So the continuity handoff finished. Pi did a custom summarization at the point that we set it to after it finished its task. And now we're starting at 4.9K context with just a small specific handoff from where we started. So anyway, that's what I wanted to share.
And the way how you build it, Brandon, it's because I'm trying to build. I'm starting to use Pi too, and basically the way to build it is just to install Pi and then ask Pi to build an extension that does X. Like,
Yeah.
what is the right way to build extensions in Pi?
Yeah, like that. So Pi is aware of its own documentation and source code. So and it includes documentation on writing extensions in Pi. So right when you open Pi, you can say, give me an extension to make this harness have this behavior, whatever it is that you want. In this case, the anti-clonking behavior. And this was just one shot. It took 30 minutes or something. And it worked. It crashed the first time, and then the second time it worked. So yeah, Pi is a super cool tool. And I think I'm going to show one more thing with Pi later because it's also relevant to this episode. But yeah, I think before that, maybe we can talk about other ways to
clean context.
yeah, to clean the context, to drain the context a little bit. Go ahead.
Yeah. One other thing that I do is also using side sessions or by the way sessions in Cloud Code. Um, so the mental model that I always keep in mind when I'm building with coding agents is for every prompt that I send, I ask myself, does this information deserve to occupy the active context of the agent doing this task? And if the answer is yes, then I'll send it. But if the answer is no, then I'll open a side session um, and ask it there. So sometimes when an agent has completed something, we might ask, I don't know, hey, did you check out that spec? Hey, what tool did you use? Hey, but these things, if they do not contribute to completing the next task, you could also ask it in a side session. And based on that answer, you can just give a clean prompt or question to the agent afterwards.
And I've shared my screen so that you can see. You just press /side in Codex and /by the way in Claude, and like an interesting. Just to be really clear, the behavior of this, I'm going to share that document again where I was talking about caching, because and the only part that is new is this. Well, the side conversation that you started. It's a branch of the chat, so it's very economically effective. Even though you're able to have kind of multiple conversations going at the same time.
Yes. Yes, it should. Yeah. I agree. It's cheap, and it really helps keeping your main session really focused on only the messages that matter.
And I guess we're back at Pi. That was fast.
Yeah, let's take a look,
So
because you
let's take a look
mentioned
at
you
Pi.
could apply this very well in Pi, right?
Yeah, Pi has a more powerful version of side chats, and by the way, that I think a lot of people don't know about. I mean, this is the most famous feature of Pi, so some people might know about it. But so it's /tree, and that actually lets you explore the that list that I showed you. It starts as a list. You see exactly all the branches that you've made, and the cool thing is, you can, well, one, you're reusing cache, which is great, and you can branch off of your branches. You can do side chats off of your side chats, which is not something that you can do in Codex anyway. But also you can, because you can summarize, you can go back to an earlier part of the tree and summarize with a custom prompt. How many words did I use? And it's kind of like you're time traveling backwards to a certain point where you get to reuse some cache and you reuse some of your conversation, but all the conversation below it, you compact, you don't compact, but you summarize it in a specific way. It's sort of like a super powered version of of all the things we've been talking about. It's like the most powerful. Yeah.
This is so cool. I know that if I had access to this feature, I would use it so often.
Yeah.
And maybe I will soon, since I'm now trying to build extension in Pi and use it.
I think like what we're doing here, if like people aren't following, we're like progressing up kind of a ladder of like more and more kind of complex things that you can do to manage your
Before
context.
You move on though, can you show us like how you change, because I'm just curious, how do you change branches in Pi? Like you showed like the tree, but if I want to go back and forth between different branches, is there an easy way to do it quickly?
Yes, you do /tree, and then so you can traverse any part of the tree that you've created, and you just go to it and press enter, and you jump to that point. And
so nice.
Yeah.
And then you could like do /tree again, and then you jump back to another branch if you want.
Exactly. So
This
is something
helpful.
like the Pi power users are using tree a lot, and they're able to have very long running sessions, but avoid any kind of compaction or clearing directly, just by jumping to different parts of the tree with custom summarization. So yeah, this is really, really cool, and I'm actually surprised that Claude and Codex haven't implemented this yet. because
Yeah.
this has been Pi's like main thing for even a year at this point.
Right. Another one to help keep the main session clean. I think actually a lot of people already use this is just moving the work to outside of your main session. And a lot of people do that by using subagents. And then, if you offload that work to the sub session, then your main session will fill up less quickly.
Yep. And we talked about this a lot in our loop and graph episode, right?
Mm-hmm. Exactly. So yeah, I think we already talked about that. So and it's also pretty straightforward. But you could also go even a step further and offload even more to other external layers. So because even though you're using subagents, your main session still needs to write prompts for every subagent that it's spawning. It needs to read the summaries or reports when the subagents come back. It needs to consolidate all the takeaways, decide on the next steps, decide and judge which next subagent to spawn, what work they need to build on. So there's a lot of orchestration that the main session has to do. But what if even that coordination you could offload? And there's this tool that Brennan and I are using, which is Beats. Do you want to explain how Beats work,
Sure,
Brennan? Because
sure.
you're the one who
Yeah.
introduced it to me.
But I don't use his original beads. I use a fork of it called beads_rust. You should make sure to install that one if you're using beads. So you can think about beads as agent native Jira, agent native task management. So agents can create tasks, subscribe to updates on tasks, comment on tasks. You can put dependencies between tasks. You can set, I like to put acceptance criteria in the tasks so that tests run automatically when an agent's completing it. And all these things live in the file system. They're actually checked into Git. And so rather than this tracking of tasks being something that just the orchestrator is doing, I mean, these days the harnesses, Claude and Codex both have task tracking in some way backed by the file system, but Beads lets you kind of use either one. But this is just an example of like taking something that otherwise would be controlled by the orchestrator or by some agent in its context window, putting it into the file system in some way, in this case through Beads, such that later agents that need to use that information, they can only look at the parts that are necessary for that part of the work.
Right. And the things that are put into Beats in this example are what are the tasks? Which task depends on other task? What is the sequence after task A, B, C is completed, then D is unblocked, right?
Yep. And this you can set up, and I do set this up, and I think you do too, Christine. This you can set up ahead of time before the work is done on like some large chunk of tasks, and so that's you're able to like move that context out of the live working session and put it ahead of time. You can also review it ahead of time, and I think that's like Beads is something that's structured for task management. You can have unstructured artifacts with just markdown files. Your agents, storing markdown files rather than communicating directly with each other. That a lot of people are doing probably by accident, or it's like very simple. But then you can even take that a step further as well.
Yeah, so we don't have a specific tool to recommend to do that now, but I will say that back in January, I was working on a project that was basically a bespoke durable state layer. So so basically the way it works is to solve this really complex math problem. The bigger math problem had to be broken down into smaller math problems. And the way to solve it is you prove that these smaller math problems work, and then you could, how do you call it? Merge them? You could.
Yeah, combine the pieces.
Yeah, you can you can combine all the pieces, so you can solve like the bigger, the top math problem. And basically, these individual prover agents that proved the smaller subproblems, they were using semantic search to find the relevant problems on this durable state layer that they could reuse. And then they would submit their own proofs, these artifacts, back to the durable state layer so the next agents could find them too and build on it.
Yeah. I think this is a cool example of like 4 problems that have this kind of shape that you can decompose them, and you don't know which pieces you want to reuse, but you know that they might be there. Then having a way to search over those pieces effectively that's built into this durable state tool could be really effective.
And if you follow this idea far enough, like what we did, and move all the way across the spectrum, it can also become architectural decisions that you're making along the way. Like, how do you encourage your agent? What belongs in active context? What belongs in a project files? What belongs in a side session? And what prefixes of the context will you reuse? So the goal is really to be intentional about what information information deserves to occupy the active context of the agent doing this task. All right. We hope that all the things that we've talked about will help you in your workflows. And if you want to keep hearing more about emerging practices for building with agents, then don't forget to subscribe. And we hope to see you next time.
Thanks, everyone.